Hi guys, how are you?
How
Hello,
are you? I'm
Maya.
good,
How are
good.
you?
How are you?
Thank you. So just I wanna talk about what we just done so far. Um, about the data processing, we started by preparing the data set, which involves handling missing values by filling in the missing entries with the mean values from each column. So this allowed us to maintain a complete data set without just losing valuable information. Next, we normalized all numerical features using min-max scaling. This ensured that all data was on the same scale, which helps machine learning models perform better by preventing large values from just dominating smaller ones. For the categorical data, like a sex column, we use label encoding to convert categories into numbers. For example, male became 0 and female became 1, making the data understandable for our machine learning model. So, Samone, can you just talk about feature selection and cross-validation?
Yes, and our second step was feature selection and cross-validation. We applied recursive features elimination to identify the most important features. Instead of using all the features, we need this method to gradually remove less important ones to focus only on the key predictors that contribute the most to model accuracy. To validate the reliability of our models, we used five-fold stratified cross-validation. This technique allowed us to split the data into multiple subsets, ensuring that our models were tested on a different parts of a data set, helping us avoid overfitting and get a more realistic sense of the model's performance. And the third step, Mahmoud, can you, told us about that?
Yeah, uh, was model development. Uh, so developed two primary models, logistic regression. And the random forest is a strong model that uses multiple tree to make predictions, while regression is a simpler linear model, good for a bunch application. Also, one of the biggest challenges we faced with the models was with imbalanced data. There were far more instances of compared to minority categories like cirrhosis and hepatitis. To address the scientific minority oversampling techniques, which generate scientific samples for the minority classes to balance the data set and give the model a better chance to learn from all classes.
So, thank you, Mahu. Thank you, Salman. I want to talk
Thank you.
about the challenges and the problems. I want to talk about handling the class imbalance. So, one of the most difficult problems we encountered was the class imbalance in the data set. The majority of the data was from blood donor cases, while there were like far fewer cases for other classes, such as hepatitis and cirrhosis. So this imbalance made it harder for the models to correctly identify patients from these minority classes. And the other thing, without addressing the imbalance, the models tended to predict the majority class blood donor very well, but often missed or misclassified the minority classes. This was a critical issue because our goal is to detect hepatitis C accurately, which requires a focus on these smaller group. Some can take
Yeah,
our performance on minority classes.
Yes, sure. The second challenges and problems that we faced during this project was low performance on minority classes. The initial models, especially random forest, performed well for the majority classes like blood donors, achieving high precision and recall. However, the performance for minority classes like suspect blood donors and cirrhosis was poor. For example, the random forest model struggled with the recall for hypothesis, meaning it missed many true cases, which significantly reduced the effectiveness of the model for real-world applicants. Uh, Even though logistic regression, when combined with smooth, improved the recall rates for minority classes, there were still classes where the models produced false positive, particularly for cirrhosis and suspect blood donors. And for the third, the challenges and problems that we faced was overfitting and cross-validation that I think it's better Mahmoud speak about that.
Sure, yeah. Another stuff were our validation. And the issue we faced was overfitting, where the models performed very well on the training data but didn't generalize well to new, unseen data. This was especially challenging because of the small number of samples in the minority classes. Overfitting could make the models unreliable when used on new patients. Also, while using five-fold cross-validation helped mitigate our fitting, we had to be very careful in how we trained the models to ensure perform consistently across different data sets.
So,
Uh, yeah,
I want to talk about what just were our achievements. We improved the model performance with a smooth. One of the major achievements was improving the performance of the logistic regression model by applying a smooth. So this oversampling technique generated additional data point for the minority classes, which allowed the model to learn more effectively from this underrepresented group. So as a result, the logistic regression model was able to achieve much better recall and precision for challenging classes like hepatitis and suspect blood donors. This is critical in real world setting, and where identifying these minority cases is key to diagnosing disease like hepatitis. And Samuel, can you talk about effective feature selection?
Yes, our second achievement was effective feature selection. Another significant achievement was identifying and retaining all 12 features using recursive features elimination. Initially, we expected to reduce the number of features, but after running the selections process that we realized that all feature played an important role in improving model accuracy. By focusing on the most important features, we made the model more efficient, which not only improved its accuracy, but also reduced computational complexity, making it more suitable for clinical application. And for third achievement, random forest and logistic regression comparison that I think, and sorry, Emma, please speak about that.
so yeah. We found that the random forest performed very well with the majority class, achieving an accuracy of 92%. However, logistic regression with smooth provided a better balance across all classes, especially the minority ones. It gave a more even performance between precision and recall. Uh, the comparison between these two models allowed us to see the strengths and weaknesses of each. And it highlighted the need for future improvements, uh, particularly in blending the models for optimal results.
And
So,
Yeah.
our next plan for the next week would be as we are just starting with the artificial bee colony ABC algorithms, and moving forward, we plan to start using the artificial bee colony algorithms. This will allow us to optimize how we blend the predictions from both random forest and logistic regression models. The goal is to combine the strengths of each model in a way that like boosts overall accuracy. The ABC algorithm will help us to find the right balance between the two models by exploring different ways to blend their predictions. Similar to how bees search for the best food sources. Simon, can you talk about
yes,
blending the model?
our second plan is blending the models for better accuracy. I think by applying the ABC algorithm, we aim to create a model that combines the high accuracy of a random forest with the improved recall of a logistic regression. This blended model will be more balanced, giving better predictions for all classes, especially the minority ones like hypothesis and zerothesis. Our focus next week, it's better to will be on integrating the ABC algorithm into our workflow and running tests to see how well the blended models perform. And for
Yeah, the next step, optimizing and evaluating the blended model. After implementing the ABC algorithm, we will truly evaluate the new blended model. Our goal will be is to see improvements in accuracy, precision, and recall for the more challenging cases. We will run tests on different parts of the datasets and ensure that the model generalize well. And we will compare the result to the visual model to see the blending has truly enhanced performance.
okay, great.
Okay. Mhm.
Thank you, guys. I think we
Thank
can meet each
you.
other on the next week.
Thank you.
Okay.
Thank you.
Thank you,
Have a
guys.
good day. See
You
you.
too. Bye.
Bye.